Hi, this will be our first video in our video series of graphs of quadratics, where y is equal to ax squared, so we don't have to worry about the other terms such as bx or the c term, the constant. So first things first, we should get to know what the value of a actually means in the quadratic equation. So a is just otherwise known as the dilation. So let's recall the graph of y is equal to x squared. It's just a parabola, right? So let's draw our y and x-axis, and our parabola is this shape. It looks like a U, but not quite, because it diverges horizontally rather than going upwards like a U would. Okay, so when we say y is equal to x squared, we actually mean y is equal to 1x squared. So what can this mean? So a is equal to 1 here, so we'll just refer to this as our normal x squared graph. Okay, so to see the effect of changing our a value or our dilation, let's try to see the effect in a table of values. So here we have x and our normal graph y is equal to x squared. Simply filling out this table where we sub in x equal to -2 all the way to 2, we'll get this. So when we plot all of this onto a graph, we're going to get a parabola, naturally. And so this is y is equal to x squared. Cool. Okay, so let's try y is equal to 2x squared. So when you sub in your x values here, you're just going to end up with twice that amount compared to y is equal to x squared, because you have 2 of x squared now. So it makes sense for the values to be doubled. And when we plot this onto our graph, we get a similar looking parabola, but it looks a bit skinnier. So if you don't have another parabola as compared to, and you're just drawing this one skinny or narrow parabola, what you need to do is you need to label a second point to describe the dilation this parabola has. So you can grab any point you want, but more often than not, we prefer to sub in x equals to 1. So when you sub 1 into y is equal to 2 squared, you just get 2. So that means our coordinate here, or our second point, will be 1, 2. Okay, so comparing this to x squared, we can say that when a is greater than 1, you get a steeper or a narrower graph. Alright, let's see what happens when you have y is equal to -x squared. So just to touch on the math here a little bit, we see that you're gonna have to square the -2 first. So when you square -2, you get 4. So inside this bracket. So once you negative what's inside the bracket, you're gonna get -4. And similarly, we get negative values across the board, except for 0, of course. And when we plot these points, we get a parabola that looks very similar to our y is equal to x squared parabola in blue, except it's upside down this time. But of course, we still need to label a second point to describe its dilation. Okay, so we can conclude that when a is negative, you simply just flip the parabola upside down. Alright, so we'll try a parabola with a dilation that's a fraction, or proper fraction, which is between 0 and 1. So in this case, we have y is equal to half x squared. You have to square the -2 first, and this will give you 4 inside the bracket, multiplied by half. We get 2. And so you get all of these points, and plotting them will give you a graph that looks a lot fatter. Okay, so to describe the dilation again, we just sub in the point where x is equal to 1, and this will give us 1, 2. So when a is a value between 0 and 1, we're going to have a flatter graph, or we can say it's wider. Alright, so this wraps up our first video on quadratic graphs where y is equal to ax squared. Thanks.